right? So here's a series that we want to prove it's convergent or divergent, or is it absolutely convergent, right? Okay, let's take a look at the series. This is clearly alternating series, right? That's observation number one. It's alternating series. So therefore, naturally, we're going to use alternating series test, right? We're going to naturally use the alternating series test for this one. So alternating series test says, what does it say? If two things happens, number one, you have a summation -1 to the n bn, and then the alternating series test says number one, bns decreasing, right? That is bn plus 1 is less than or equal to bn, right? Number two, limit n going to infinity, bn is equal to 0. If these two conditions happens, this is convergent, right? And so is the question, is it absolutely convergent or conditionally convergent? You can say it's not absolutely convergent, because if we take a look at the absolute value of this one, that is going to give me 1 over square root of n plus 1, right? So which is essentially 1 over n plus 1 to the 1 half, and this is like this is going to behave essentially like 1 over n to the 1 half. So by the limit comparison theorem, we can see that since the by the p series test, this is, since p is less than 1, this is divergent. So therefore it's not going to be absolutely convergent. So this is not definitely, this is not absolutely convergent, right? Not, that is not possible. So if at all this is going to converge, it might converge from this alternating series test, right? And if it converges, it is going to be conditionally convergent. It is going to be conditionally convergent. That's what is going to happen, right? So it cannot be absolutely convergent. So the least it can be, or the best it can be in this case, is the conditionally convergent. Let's see if it satisfies. As a matter of fact, it satisfies both conditions. We take a look at the condition number one. The bn, which in this case would be 1 over root of n plus 1, square root of n plus 1, right? And then your bn plus 1 is going to be 1 over square root of n plus 1 plus 1, which is coming from here, right? n plus 1 right there, which is 1 over root of n plus 2. As you can see here, the denominator got bigger, right? So therefore, bigger than this guy. So therefore, as the n gets bigger and bigger, the whole value is going to get smaller and smaller. So you can clearly say 1 over square root of n plus 2, which is bn plus 1, is less than, in this case strictly less than, 1 over square root of n plus 1, which is equal to bn. So the condition number 1 satisfies, right? The condition number 1 is satisfied. Let's take a look at the condition number 2, that is finding the limit of n going to infinity, bn, right? Let me do that one. If I do that, it's going to be limit bn, n going to infinity, which is limit n going to infinity 1 over square root of n plus 1. As you can see, as n goes to infinity, the whole thing goes to 1 over infinity, which is 0, right? So you can say this is 0 right there. So it also, second condition is also being satisfied in here. So therefore, so this is satisfied. That checks out, right? This also checks out. Therefore, by the alternating series test, the alternating series test, the series n going from 0 to infinity negative 1 to the n over square root of n plus 1 is convergent, but it is not absolutely convergent. Therefore, this series is conditionally convergent. It is conditionally convergent. And that is the view of the problem. Is it okay? Yes.